Before we start with our session, let me just give you this important announcement. They are very important in the sense that you recall that you missed a test. You didn't write a test on the. Actually, we postponed a test on the last week, and then we have agreed that you are going to write it on the 22nd of April, which is this coming Friday. Are you aware of that?
Yes, sir.
Okay, thank you very much in that regard. But remember, we have already scheduled. There is somebody who's Mawunda, Mr. Mawunda, please. Okay, thank you
Sorry,
very much.
sorry.
Thank you very much. You still remember that I scheduled the quiz number 2 from the 20th, which is today, to be written on Friday, which is the day after tomorrow. And then there comes another assessment, which is a test, which is going to be written again on Friday. I think you are still going to write a quiz because the quiz is in the morning, and then the scope is almost the same. Yes.
So we are supposed to write twice.
What's wrong? Well, it's the same thing, isn't it?
Mara said that's
Quiz,
too much.
quiz is well, because if you can't write on Friday, so when are you going to write it? When are you expecting to write it again? Okay, let me just
Move it
find it from
Saturday.
you. Eh? Come
You can
again?
move it to Saturday.
Saturday.
Yeah.
Okay, let me just. Is everybody agreed on that? Okay.
Sir, yeah.
Eh.
Can you repeat what you said? The network cut me off.
I was saying, remember that you were supposed to write a quiz on Friday, and again you have to write another assessment, which is test number 1 on the same Friday. So I was saying that I think it would be good if we just write your quiz in the morning, and then in the afternoon you write your test. Then somebody suggested that no, it's going to be too much for them. So he's suggesting that we can just shift a quiz to be written on Saturday.
Oh, okay. Thank you, sir. Thank you.
So that means you agree that we can just shift a quiz to be on Saturday.
Yeah, I mean, yeah.
Okay, it's fine. Then we will agree on time later, maybe on Friday, because we are going to have a class. Okay, it's fine on that. But I wanted to find out from you, are you aware of the test on Friday?
Yes, we
Yes,
are ours.
Okay, test on Friday, venue still TC, time is 2 o'clock. So you have to be clear on that. So I think I wanted to just announce that important information. Now let's continue with our session. You will recall that we have covered chapter 5. We're done with chapter 5, and then I gave you something to deal with, which I suppose you did. If you have any challenges, you can let me know. So today we are going to move on to chapter 6. Chapter 6, according to the lecture notes, it's about residuals. Chapter 6 is on page 41. Model diagnostic, but anyway, we are going to consider more on residual analysis. So let me just open the window journal so that I can write something on it.
We know that the product will give us the product. The form of x and y will give us the expected value of x, y, minus the expected value of x times the expected value of y. So, for us to find the expected value of x, we must first find the marginal, or the marginal of x. In this case, is 1 with the length of
Yeah, I see that.
Yes, I'm still opening the window journal. Please be patient.
Oh, okay.
Can you be able to see it? Hello?
Not yet.
Not yet. Okay, let me just see. Be patient. I'm still opening it. It's taking time.
Sir,
Yes. Wait, I'm still opening it. It's taking time. I don't know why.
I didn't hear you when you made the announcement. The network cut me off.
Oh, we are postponing the quiz. You're going to write it on Saturday. Isn't that you were supposed to write it on Friday? Did you get it?
Yes.
Yeah. Okay, there we are. You will tell me when you see the window journal. Is there?
Yes, we can see that.
Okay, thank you very much. This is what we did last time. So now we can move to the next. This is what we did. Okay. So chapter 10, but remember it's lecture 22, this one. Okay, let me just write it down. 22. And then it's chapter 6. It's chapter 6. And it's about residual analysis. Residual analysis. Okay. So now, what is residual analysis? Okay, residual analysis. What is residual analysis? So residual analysis is used to determine the adequacy of the model. Okay. So in other words, in order to check whether the model is adequate or not, we use the residual analysis. Now, Residual on its own is defined as the actual values or actual observations, actual values or actual observations minus the fitted values or predicted values. Predicted values. Okay. So that is the residual. Now, there are two types of residuals. What are they? We have got the residual autocorrelation functions and residual partial autocorrelation functions. So in other words, types of residual. Okay. We have got what? Like I said, residual ACF, meaning that residual autocorrelation function and residual partial autocorrelation function, PACF. Those are the two types of residual. In other words, in order to check for the residual, for the adequacy of the model, it's either we use actually both of them, residual autocorrelation plot and residual partial autocorrelation plots. Both of these plots, let me say plots here, both of these are used to determine whether the model or the data is a white noise or not. It's a white noise or not. So in other words, you have to plot the residual autocorrelation function and the residual partial autocorrelation function plots. Then from there, you check whether indeed the model that we are dealing with or the data that we are dealing with is a white noise or not. Now, to determine the residual autocorrelation plot, if they are adequate, you have to check the significant difference from zero using Portman-Tew test. So in other words, can I move to the next page?
Yes.
Yes.
Okay, thank you. Now, to determine whether the residual autocorrelation function functions, let me call them more functions, significant significant different from 0. Different from 0. We use the portmanteau test or box piece test. Okay, those are the tests that you can use in order to check whether the autocorrelation plots or the residual autocorrelation function are significant different from 0. So now, immediately when you talk about significant different from 0, that means you have to state the hypothesis there. Okay, so what are the hypotheses that we are going to consider? So the hypothesis in other words, we are talking about null hypothesis and alternative hypothesis. So for null hypothesis, which is HO, we just want to check if the autocorrelation function at leg 1, leg 2, up to leg k are equal to 0. In other words, row 1 must be equal to row 2 up to row k, depending to the number of k. All of them must be equal to 0. That is the null hypothesis. Okay. The alternative one, we check whether row k is different from 0 for at least 1 k, where k is ranging from 1 up to k, bk. So now here you have got the hypothesis, null hypothesis and the alternative hypothesis. The null hypothesis, the autocorrelation functions at leg 1 must be equal to the autocorrelation functions at leg 2 must be equal to autocorrelation functions at leg 3 up to autocorrelation functions at leg k, depending to the number of legs. All of them must be equal to 0. However, the alternative one, the autocorrelation functions at leg k, where k is ranging from 1 up to k, must be different from 0. In other words, if you find one autocorrelation function, let's say, for example, row 1 is different from 0. So therefore, the model is not what? It's not adequate, or the data is not quite adequate. Okay, if you don't want to use this hypothesis, you can use these ones. HO, which is the null hypothesis again. You can talk about the data or the model. Let's say the model, you can say the model is a white noise. Still the same thing. It's the white noise. The model is a white noise. Simple means that autocorrelation functions at leg 1, leg 2, up to leg k are equal to 0. That is the model is a white noise. It's the same as the one above there. There is no difference. In other words, you can just write your null hypothesis as the model is a white noise, or you just write row 1 equal to row 2 up to row k. All of them must be equal to 0. It's the same thing. Are we together? So what about the alternative one? H1, so it's the opposite of that one. The model is not a white noise. Okay. Not a white. It's not a white noise. That is the alternative one. The third scenario You can take your null hypothesis as what? The model is adequate. The alternative one is going to say what? The model is not adequate. It's still the same thing. Or if you don't want to use those ones, you can use these other ones. The null hypothesis as the model is good. We mean that if the model is good, it's a white noise. If the model is good, we mean that the autocorrelation function at leg 1 is equal to autocorrelation functions at leg 2, which is equal to 0. Okay, that is the null hypothesis. The opposite of that, the model is not good. The model is not adequate. So that is the alternative one. So you can just write one of those things there. All of them are correct. Are we together?
Yes, sir.
Okay, now let's just go to the test statistics. Like we said we're going to use the portmanteau or box piece test. This is the one that I talked about. So we're going to use this box piece test or portmanteau test to compare with the chi-square test. Are we together? You're comparing the box piece test with the chi-square. If the box piece is greater than the chi-square, therefore you can reject the null hypothesis and take the alternative one. Now let's continue and show you. Portmanteau test is given by or sometimes call it box piece. Is given by Q. The letter Q represents the portmanteau test or box piece test, which is defined as what? N multiplied by the summation, where K is ranging from 1 up to K, okay, of rho K squared. Okay, where in this regard, where N is the population size, referred to be a population size. So in other words, you will be given a data, or maybe they will tell you that the population size of this is so much. However, if they didn't give you the population size, you rather use the sample size. So in other words, they are going to give you a sample size, n, small n. And normally sometimes they gave you k. Sample size sometimes is equal to k. Okay, so n, like I said, is a sample size. So in other words, what I'm saying is that if here they didn't give you the population size, you are allowed to use what? The sample size. If the sample size is not given and they use k, so you just equate your k to be n, where n is a sample size. Are we together?
Yes, sir.
So what about k? K stands for the number of legs. K stands for the number of legs. Okay. And then what about rho k? This one you are familiar with. Rho k is the autocorrelation function at leg k. This one is the autocorrelation function at leg k, where k is ranging from 1, 2, 3, and so on, up to bigger k. Okay, depending to how many legs are you going to have. So this is your portmanteau test. So now let's come to the chi-square, because I said you have to compare your portmanteau or box piece test with your chi-square. So what about the chi-square? Chi-square. So chi-squared is abbreviated as this, kp minus q of alpha. Okay. So where in this regard, k we have already defined it. Alpha is the significant level. So what about p? P stands for what? P is the order of autoregressive. If they gave us the process, autoregressive process, you have to know the order of that autoregressive process. So in other words, P is the order of autoregressive process. Okay. What about Q? Q is the order of moving average process. Okay. So if they didn't give you the process, that means you don't have an order of autoregressive or order of a moving average. So your chi-square can be k alpha, because your p is going to be 0 and q equal to 0. If p, let's say p and q, all of them are equal to 0. Are we together? So this is how to do it. So you can reject the null hypothesis. You can reject the null hypothesis if q is greater than a chi-square. Let me just write it down so that you can follow. Go to the next page. What I'm saying is, if q, which is the Portman-2 test, is greater than the chi-square of k minus p minus q alpha, what do? We reject. We reject the HO. What is the HO? The null hypothesis, whether, depending to how we define it, reject that the model is good, reject that the model is adequate, reject that the autocorrelation functions at leg 1 is equal to leg 2, autocorrelation function at leg 2, which is equal to 0. You reject that statement. And then what? You take the alternative one. Are we together? However, if the Portman-2 test is less than the chi-square, so we fail to reject the HO. So in other words, we take it as what? As a white noise. We take it as what? As the model is good. We take it as what? As the model is adequate, and so on. It's clear.
Can you repeat that statement, sir?
The last one.
Yes.
I was saying, if Q is less than the chi-squared, okay, of k minus p minus q, so we fail to reject, isn't it? The HO. If we fail to reject the HO, in other words, in conclusion, we are saying what? The model is a white noise. Isn't that we fail to reject? We are saying that the model is a white noise or is adequate or is good or autocorrelation functions at leg 1, which is row 1, row 2, and so on, up to row k, all of them are equal to 0. Okay, I think it's clear. Now, let's go to the example on how can we apply that. Example, let's consider example 5.2.1.8. I think it's there on the lecture notes, but anyway, I'll write it down for you. Example 5.2.1a, page 38. Okay, let me just say example. It's 5.2.1a, and it's page 38 on the lecture notes. Okay. Okay, let me just write down the table for you so that you can recall something that we did before. Can I go to the next page, please?
Yes.
Okay. This is a table.
Say, is that K or
Yeah.
R?
It's K. It's K, please. Sorry. It's K. This is K. Let me write it nicely. This is our K. The next one is XK, and the next column is row K. 2, 3, and then 4. K is ranging from 1 up to 4, and XK is ranging from X1, X2 up to X4, with these values here 4, 5, 2, and 5. Something that we did before. And then, if you still recall, I asked you to calculate the autocorrelation functions at like K. Then we find row 1 to be minus 0, 667, I suppose. Minus 0, 667. Minus 0, 667. Okay, that's what we got. The next one, if you still recall, we got 0, 167. Okay, and then the next one we got 0, and this one we got 0. Something that we calculated before. So we just want to use this table to do what? To test whether the data or maybe the model is adequate, or the model is a white noise or not. So I want you to calculate this. Let's start by calculating, or state the hypothesis. You have to state the hypothesis first. Or let me just write the question. Check whether the process is a white noise or not. Whether the model is a white noise or not. We're going to use the table to check whether the, can you say data, or if you don't want to use data, use the model, is a white noise or not. So in this regard, you're going to compare the portmanteau with the chi-square. So the question can say, check whether the data or the model is a white noise or not. Or check whether the data is adequate or not. Or check whether the data is good or not. They just gave you the table, then later they said check whether the data is a white noise or not. You must know that in this regard, you have to find the portmanteau test first, Q. Okay, that's number one. Number two, you find the chi-square. So they will tell you that if you have 95%, what? Say you're going to use 95% in this regard to talk about this. So we're going to check. So you must know that your alpha equal to what? If you have been given 95%, your alpha is equal to what? You can tell me.
So what will be the final answer?
5%, sir.
Yeah, 5%, which is what? 0.05. Isn't it? So you're going to use this one. So in other words, here you're going to have chi-square, okay, minus p minus q, 0.05. Then you'll find it there. So remember, because they didn't talk about the process here, they didn't mention autoregressive or moving average process. So obvious our p is 0 and q is 0. So that means this one falls out. Then you are left with what? With k. So k is equal to what? You can tell me. K equal to?
Four.
K is equal to 4. So now, what is the chi-squared of 4, 0.05? So if you check your lecture notes there is a chi-square table at the back. For those who are reading it, just check at the back. There is a chi-squared distribution there, right tail probability on page 47, and another table is the t distribution. But at this point in time, we're looking for what? Chi-squared. So it's 4 and 0.05. Then you go to, I think it's column number 3, with 0.05, and then 4, I think it's 9, something. Do you have a table? Can you tell me the answer?
It's 9.488.
Yeah, that's correct. 9.488. So now we got our chi-squared now. Let's find our portmanteau test. Statistics. Let me just go to the next page to calculate Q. So Q, like I said, is equal to, because here we don't have the population size. Instead, you are having what? The sample size. So it's like this. K starting from 1 up to what? Up to 4 of rho K squared. Okay. Then which is equal to what? 4 open brackets. So rho 1 square, rho 2 square, rho 3 square, rho 4 square, which is equal to 4. What is rho 1? It's minus 0.667 square. Okay, plus 0.167 square, plus until those other ones are zeros, isn't it? Okay, tell me the answer there. Please tell me the answer.
1.8911.
1.891. It's 1.891. That's the answer. So now we just want to compare the portmanteau together with the chi-square. Can tell me, is Q greater than chi-square?
is less than, so which means
It's less than. So since Q is less than chi squared, K or alpha, then we do what? We fail to reject, isn't it?
Fail to reject.
we fail
To
to
reject.
reject.
To reject. Yeah. Fail to reject. Sorry. Reject HO. Then in conclusion, you know what to do. If you fail to reject, so you have to conclude. You can tell me in your conclusion.
It is a white noise.
Yeah, therefore, the model is a white noise. That's it. This is how you check using the test statistics whether it's a what.
See,
Hmm?
don't we have to emphasize the percentage like that we use on the conclusion?
Or 95%. That one is not
Yes.
necessary. You can just in a broad, maybe in your conclusion, you can add that one. There is no harm on that. But the main idea, we just want to check whether the model or the data is a white noise or it's adequate or not. You can just include even the percentage if you just want to make your statement to be more powerful. There's no
Okay,
harm on
no
that.
problem.
Okay. Now, let's go to the exercise now. Exercise regarding that, it's on page 41. Is it page 41? Sorry, not that one. No, it's not page 41, but it's page 43. Okay. Let me just go down there. Say exercise for you. It's on page 43. Okay, I'll write it down for you. You have been given this statement. They are saying the autoregressive of order 2 model, okay, given by xt is xt equal to c plus alpha 1 xt minus 1 plus alpha 2 xt minus 2 plus zt is a fitted data it's fitted to the data, sorry, to a data set of length 121, sorry. That is the statement. Then later they said the box piece apartment 2 test statistic value is Q equal to 121. It's 121 summation K equal to 1 24 rho k estimate square, which is equal to 31.5. Okay, they've already calculated the box piece statistic for you. So the question says at 95% level of significance, test the hypothesis that AR2 model fit the data. That is the question. So I can just make it simpler for you. So I want you to, number one, state the hypothesis. So you have to state the hypothesis. Then from there you compare the box piece and the chi-square. Then from there you write your conclusion. So, but anyway, I want you to state the hypothesis first, and then from there you find the chi-squared. After finding the chi-square, you compare with the portmanteau. After comparing, then you write your conclusion. I need to state the hypothesis. The two things that I need is the conclusion or conclusions. It depends. I need this one. This one must be there, and this one must be there. Yes, you can start now.
Yes, I was saying that the correlation coefficient given by rho of x and y is equal to the covariance of x and y all over the square root of the variance of y of x and the variance of y. Is it clear? Is it clear now, Papa?
So I'm giving you how many minutes? Let me say 8 minutes. Finalize everything. It's very simple.
The covariance of x and y, I think it was -5 to 100. Okay? Now, you need to calculate the variance of x as well as the variance of y. And when you calculate the variance of x and the variance of y, you won't use the grand basis or the bivariate. You must use your marginals. The same way you calculated the expected value of x as well as the expected of y. Or how you answer B. When you are answering B, you are taking all the marginals of x and y. So you must also use the marginal to find the variance of x and the variance of y. Remember, they wanted you to use the derivative, they were gonna say find the derivative of x, y. Are we together? Are we together? Ladies and gentlemen, are we together? Ladies and gentlemen, are you following? All right. So this one you can do on your own time because
Are you getting it?
you can find the value of x and the value of y. Can you hear me? Can you hear me, guys? Guys, are you able to hear me? Do you think they able to hear me? Can you hear me, guys? Guys?
Said we are done.
You're done. Okay. Now let's do it. Let's start with the hypothesis. Let me just write them here. The hypothesis. There are two. Okay. The null hypothesis is what? You can tell me. What is your null hypothesis? Anyone? What is the null hypothesis?
The model doesn't fit the data. The model
The null.
doesn't fit the data.
That is the null. Not the alternative.
The model ER2 feed the data.
Yes, that is the one. AR2 or autoregressive of order 2 model fit the data. Well, you can just say the model, or you can just say autoregressive of order 2 model fit the data well, or just say the model fit the data. You can say fit the data or fit the data well. It's the same thing. The model fit the data or the model fit the data well, or autoregressive of order 2 model fit the data. Still the same thing. Okay, that is the null hypothesis. The alternative, the alternative one,
The model
The model does not feed the data.
yeah, the model doesn't fit the data. The model, does not fit the data. So now, somebody can just say, okay, I don't want to write this one, autoregressive of order 2 model fit the data. But I just want to say what? The model is adequate. It's okay. Okay. And then alternative would be what? The model is not adequate. So it's still the same thing. Okay. Or you use that other one, autoregressive of order. Autocorrelation functions at leg 1 is equal to autocorrelation functions at leg 2 up to autocorrelation functions at leg what? Leg K. Okay. Still the same thing. And leg K at this time in point K is ranging from 1 up to what? Okay. Now, we have stated this one, the hypothesis. Then I want you to find the chi-square now. Chi-square, what are the parameters? Obvious, our alpha is 0,05 again. What are the parameters down here? What is our K?
24.
K is 24. It's 24 only. So chi-squared is 0,05
Minus 2.
Minus 2.
Yes. Yeah, that's it. Which is equal to what? The chi-squared 22 0,05. Then you tell me the answer of that one.
When they say conditional density function, all that they are saying is that
Anyone who's having a table must tell us.
I got 33.924.
33.924. Who is it? Yeah, 33.924. 33.924. That is the answer. So now, compare the portmanteau with the chi-squared.
Chi-square is greater than Q. Therefore, we're going to else reject. And we conclude that the model fit the data.
Okay, since you said chi-squared of 22 0,02 is greater than portmanteau. We fail to reject HO. Then in conclusion, so the model fit the data well. So that's it. This is how you check if the model fit the data or if the model is a white noise or not. I think you can stop here, unless if you have any question. Because this is chapter 6, we are done. So we are left with chapter 7, which is forecasting. So now, if you have any question, you may ask.
Say, I want to ask you,
Hmm.
how do we say, okay, like, if maybe we are given a question, how can we see that the order of the moving average process is not zero in some other cases?
Oh, okay. It's when you have got ARMA. You know that ARMA stands for ARMA process. So when they gave you ARMA process, here they gave you autoregressive of order 2, remember? So in this case, if they gave you ARMA process, obvious is going to be defined as xt minus phi 1, xt minus 1, which is equal to, is it get zt plus theta 1 zt minus 1. You see this one? This is the ARMA 11, okay, process. So where P, the order of P, is equal to, we're assuming that the process is stationary and is invertible. Okay, our P is 1 because it's of order 1, isn't it? And our Q is 1. Okay, so now if you want to use the chi-square, so you're going to have k minus 1 minus 1. Obviously, it's going to take you to 0. so of alpha. So again, it's going to take you to k of alpha. So this is when you have got ARMA process, when you are going to have both autoregressive and a moving average. This is how your chi-square is going to be represented. Did I answer your question?
Yes, I understand now.
Okay, it's fine. Any question? So let me just stop here if there is no question, so that you can just go and prepare a test. Prepare for a
I need
test.
clarity on the
Mm.
for the quiz and the test. Is it the same scope, or maybe for the quiz it's different?
I think for a quiz, I think it's different. I gave you a scope there on Blackboard for quiz number 2, if you still recall.
Okay, I will
If
check
you,
it.
yeah, just go and check it. But I think I said from chapter 2 up to chapter 5, if I still recall. Chapter 2 up to chapter 5, that is a scope of quiz number 2. But for quiz number 3, I'm still going to give you the scope for that. For
Okay.
test, it's the same scope because you should have written this thing long time ago.
Okay.
Okay. Any question?